Good afternoon. On behalf of QCrete India Private Limited, I consider it an honor to me to introduce engineer Jose Korean. I can say we are very fortunate to have Mr. Jose Korean with us to do this presentation on sustainable concrete. Mr. Jose Korean, he graduated in 1986 in civil engineering, 68 in civil engineering, and he did a course from IIT Delhi. He also holds PG diploma in earthquake engineering from International Institute of Seismology and Earthquake Engineering, Japan. He was involved in many projects, important projects across the country. Some of the examples can be Jawaharlal Nehru Stadium in Delhi, ISBT flyovers in Delhi, renovation of fire damaged structures, Udyan Bhavan in Delhi, Parliament Library building in Delhi, Madhuban underpass 1.2 km long Lajpat Nagar flyover, 2 underpasses in Premapurial and Boca Chand intersections on Ring Road, Delhi, community skill parks for ASCP, Government of Kerala, to name a few. The list is very big. One of the greatest achievement we can say is Mr. Jose Korean was the chief engineer for conceiving, planning, design, and construction management of the signature bridge across River Yamuna at Wazirabad, as well as number of tourism development parks. We can say this is one of the, you can say, a signature project of Mr. Jose Korean. He was also on many BIS committees. The list is very big. Like one of the examples are he was on CD2 on cement and concrete, and also a member of BIS committees like 456 RCC code. He is convener of National Building Code panel for concrete. He is also an active member of BIS panel for construction project management. And the list is, as I said, to be frank with you all, we cannot capture his achievements in 10 minutes or 5 minutes in words actually. I can say he's like a walking encyclopedia. He's also former president of Indian Concrete Institute, chairman, steering committee of RMC certification, Quality Council of India. So he has done a lot of contribution in Quality Council of India, member of Research Council of National Council for Cement and Building Materials, etc. He has received many awards. Some of them are Lifetime Achievement Award in 2016 from Indian Concrete Institute. He was also recipient of CIDEC Vishwakarma Public Officer Award 2011. In addition, he has received Best Paper medals from Indian Roads Congress as well as Indian Concrete Institute. So I repeat once again, we are very fortunate to hear from one of the greatest engineers India has produced, and we are thankful to you. Now the floor is for you. Thank you.
Thank you, Mr. Kaushik, for the elaborate introduction. I am extremely fortunate to be available today to speak to all of you, and I must especially thank QCrete India Private Limited, who has organized this event, which is extremely appropriate that as we are all locked down in a very unfortunate situation across the world, we get updated on what has already happened and what we can do in future. So I consider it is a very good opportunity to talk to all people. I am very sure you are all working from home, and you will be looking forward to know what is available, what we can do as engineers. The coronavirus has really overwhelmed the whole world, including professionals like us, because we are one of the most affected parties, because most of us as civil engineers work in the field. and most of us are allowed to not to go out and do our job. I hope things are slowly opening up, and we will be able to achieve what we have been doing and do better. Only thing is that we all will have to change in our thinkings, change in our attitudes, and change in our approach. And mostly fundamentally, we'll have to change our ideas about how to do the work which will be useful for the society. My topic today is on sustainability. Sustainability, especially, I've chosen only one material, concrete, but sustainability is such a big issue. As one of the reasons, may be correct, may not be correct, quoted across the world for the occurrence of such a pandemic is mostly the degradation of the environment. And because of the climate change and so many other major reasons are noted as the reason for such pandemics coming again and again, and as well as other disasters which is coming to confront us. And as civil engineers, we are often blamed for the such degradation of the environment. This, rightly or wrongly, we have to face, and it's an opportunity for us to hear from other people what wrong we are doing, and that gives us an impetus to work better and improve our field of work. Mostly, if you closely look at it, as civil engineers, we do improve the quality of life of people, no doubt about it. And in the process, many of us don't understand the work that we do and the kind of efforts we make to make this environment better. So that was the idea for me today, to introduce you what in the construction field, what is available for us, what we can do, or what we are already doing, how to improve it. And I take just one material, concrete, which we all are dealing with, to see how much things can be done and how much we are doing, and still how much things are ahead. Now, this is a job which has to be done by not only by practitioners, but researchers, academicians, sociologists. There are a whole lot of people, finance, economics, everything put together to make this whole world a better place again. And our role as civil engineers are not so small. So that was the idea. I thought that an introductory lecture coming from me should focus on that. And I must confess today, I'm not going into great detail of what exactly on each of the topic, because the sustainability is a huge field. You know, the UN is involved, and we have got many treaties, and we are, in the civil engineers are also engaged in the whole part of the treaty, and so many things can be done. So what I'm going to do today is to just give you certain ideas on which ideas which are possible, which are doable, and which can be done. And maybe other occasions we can take each one of them and analyze and see where we can contribute and in which directions to grow. So my endeavor today will be to just point out what are available in the field of the sustainability for a civil engineer. So this idea, I'll open my slides for you. So if you look at the construction industry, it has an immense effect and impact on the overall economy of any nation. It's not really India. And in this country, because we are far from developed and developing in a faster way, we all want to grow. And one of the major contributors is the civil engineering, because the most important and the most fastest growing and what should be done is the infrastructure. And in creating infrastructure, you all know that how much contribution the civil engineers and the construction people have to make. And we contribute immensely, a major part of the GDP. And if you look at the 12th five-year plan, you can see how much of contribution to the national economy we do make. So this being an important and a very major part of the economy, how we can contribute as civil engineers to the sustainable development of the entire world or the country. We all know that the basic definition which is accepted by the UN, the United Nations, on what is sustainable development. This is the always often quoted. I'll quote again, even for without, I mean, even if it is repeated, the development that meets the need of the present without compromising the ability of future generations to meet their own requirements. So this is the whole idea. In nutshell, our idea is that we should grow, but at the same time, we should leave enough for the next generation, which is our children. Our children's children are coming. So this is the whole idea. So what exactly is the sustainability? If you look at it, this is a state in which the components of the ecosystem and their functions are maintained for the present and future generation. So once we take any decision, once we take any action, you have to, a major part of such decisions and action should be with the future generations in our mind. So this is the whole idea. In construction, it relates to how attributes of the activities, materials, products, or services used in construction work or use of construction work contribute to the maintenance of the ecosystem components and functions. Also should be able to look after the future generation. So whatever actions we do, whatever materials we do, how much material we should use, how much should be left for future, how much we can do with the services we do, it should not at any time compromise the chances, compromise the future, and compromise the future generations' activities. This is the basic idea in which the whole world is working. So if you look at this scope, what we have to do, one of the major, what we do, we are one of the major consumers of the natural materials in the whole world. Civil engineers consume a whole lot of natural resources, and so we should understand which are the resources that can be tapped, so that they can be efficiently employed, efficiently processed and used. So how much of such material should be utilized in our projects, and how much should be left for the future, and how much energy demand, how much we can optimize when it comes to use of energy, because we all know that energy is one of the major polluters. At least a major part of the energy is also pollutes the country. So based on those actions, it also leads to a lot of emissions, and such emissions are the major problem for the climate change and so many other actions that are coming out of it. So how much of those emission loadings we can reduce? So this is another thing that we should look at it. So the way to go forward would be to look at the life cycle impact. We'll discuss about what is one of the most key elements that as a civil engineer we are supposed to look at, but we are still not reached a stage in which we are all able to look at this life cycle impact on all our activities. And then we have disasters, whether we would like to to face it or not. Disasters do come. A whole lot of them are man-made, whole lot of them are not. But we have to confront both and take decisions and take actions so that we face them and continue with our life. And then one of the major issue is the commuting and transport, which we cannot do away with. But we have seen during this lockdown how we are able to overcome such a disability in terms of commuting and transportation. We are learning. For example, today I am sitting at home in front of a small laptop and able to reach all of you who are distantly placed in anywhere in the world. And along with another laptop or a mobile phone, we are able to cut short the entire commuting and transport. Normally, we should have been sitting in a seminar hall or an auditorium and listening to each other. But we are able to do this, with which we have saved a whole lot of energy for transportation. So this is the way the life should change. Life should change for all of us. And we should look at how much we can do and reduce the transportation so that the world is a better place tomorrow. So this is the idea. So how do we manage this sustainability? There is no doubt that climate change is happening, and we should confront it. And our idea is to manage the climate change. We cannot stop the climate change at all. we all do a whole lot of treaties and agreements and try to do the best in terms of the parameters that we like to do. But the only way we can do is technology. So this has to be admitted that technology can, to a great extent, look at in reducing or looking at when you look at sustainability, technology is the key. For example, today we are looking at the things and we are using a platform to do this work. So that is one technology in terms of communication, in terms of presentation, in terms of audio. There are so many things that are happening here. So how cannot we bring in the field of civil engineering also? The technology should be harnessed more and more in our day-to-day activities to manage this change that is happening across the world. So this is one thing we should look at it. We have to use as much of technology. For example, we have brought ready-mix concrete into the fore, with which is a technology which will definitely help if you look at overall calculate the whole cost of producing concrete. RMC is going to do a whole lot of change, and we have to improve the technology and use such technologies more and more. We will go along, as we go along, we'll discuss such technologies which has got a direct impact on managing sustainability. So if you look at one of the basic codes of the International Standards Organization 14001, we will look at the basic concepts which they mention in the code, which is the basic code we all use. Reduce the raw material or resources that we use. This is the basic thing. What we can do is, suppose we are using today 100 cubic meter of a particular material, either cement or sand or aggregate. Can we manage the same with 50? Or 90 or 80 or 50 or 40? So this is the way we have to look at it. This requires an immense use of technology, immense use of research, immense use of training, conveying the ideas to each other and get put into the practice. So this should be one of the idea that we reduce the use of such resources which are scarce in the nature, because nature cannot keep on producing material for you. And then reduce the energy consumption. This is another way, another thing. Can we use with lesser energy by putting more efficient systems and efficient wastages of energy, so that we reduce the energy for the same activity that we are doing with 100 watts? Can we do it 90 watts, or one day can we do it half the energy that's required? And so the only way is to improve the processes. Every work that we do is a process. Every activity, when producing concrete or pouring concrete or curing it, everything is a process. In each of the processes, we can always, as an engineer, we can analyze and see how much of those wastages can be avoided, how much more efficiency can be brought into each of those processes. That will definitely improve the process and definitely reduce the energy as well as the material that are required. And then in every one of the activities, we do generate waste. How can we reduce that waste itself? Can you reduce the waste of resources? Suppose we use aggregates, for example. In the process, how much aggregate gets wasted? So that is another thing that we'll have to look at it. In every activity, how much of reduced waste can be reduced? And then all those wastes, can it be recovered? It's possible by recycling. Whether it is possible, can we reuse them? These are the other idea we'll have to look at it. So right at the beginning, when we start a process, we should look at a plan. We should have a recovery plan. And the recovery plan should look at how much of those things can be reused, how much of these materials wastage can be recovered. So this is and reused. So this is the issue that has to be looked into every activity of a civil engineer. This is one thing. So what are the challenges that now we are facing? The aggregates are just not available because nature cannot keep on producing. In Kerala, for example, where I'm talking from, we are facing a huge shortage of aggregates. The courts are not allowing to mine sand from the rivers. You cannot mine aggregates from the hills or quarries. So there is a whole lot of aggregate shortage. So what should we do? We use whatever is available readily. and use them more efficiently. What we have been using a whole lot of things, reduce it. And then you have to look at the durability. This is one of the most important issue when it comes to sustainability. When we produce a thing, if we were designing a building for 50 years, can't we design it for 100 years? Yes, we have already changed our code that the minimum life cycle of a project, a building, should not be less than 100 years. It is possible to design them, and there are a whole lot of methodologies are available, the codes are available. Now we look at the durability aspect of a structure. First you design it and make it that, see that it is durable. And by making it durable, what exactly are we doing? Suppose I make a house for somebody, X, I'm making a house for X. And it was designed, it was supposed to be used for 50 years. If I'm able to make it use for 100 years, what exactly I'm doing? I'm reducing the use of material by 50%, isn't it? So that is the whole idea, making a building durable or making a structure durable. We are reducing the consumption. That is how one of the ways of reducing the material. In the process, we are also saving the energy, isn't it? We are also saving the energy because every construction requires energy. Equally important is to look at the health aspects of not only the people who are going to live there, the people who produce the material, people use them, people who live in those structures, people who use them. We have to, and who work for them. We have to look at the health of all those people. And leakages happen because the leaching, there are many things leach into the air and spoil groundwater. There are a lot of things. We should also look at the pollution that is happening, not only because of the emissions as well as the dust. Noise is another issue in cities and other places. Can we reduce the noise that we create in construction, building, piling? There are many other things which will become difficult for people to suffer. So we'll have to have standards in for noise production and reduce it. Radiation is another thing. When we use some of the radioactive materials, see that such materials are used with proper procedures. Safety is one of the most important issues, both structural safety as well as people safety. We should look at so that there is not a single life is lost during construction, and there is no injury that happens to our workmen, and no injury happen to all those people who use our facilities. So this is another issue. Water in the whole world today, water is one of the most simple issue which is staring at us because we don't have enough water. So civil engineers do use a lot of water. How can we reduce the use of water in our construction? Or if at all we use for construction, can we recycle them? Can we reuse it again and again and again? So that one is net zero. Whatever we take, we give back. And that is another thing, water harvesting. There are a whole lot of ways to save water. And of course, as we discussed, waste, minimum waste. And whatever waste is there, let us recycle them and reuse them. And only a minimal amount of waste should go out of our sites. In fact, in the new agreements, these are all should come into the construction documents. In the Delhi, when the CPWD is awarding works, major projects, it is a criteria or a condition in the tender, in the agreement, that not 1 ton of waste material should go out of the barricades. You have to use the entire, whatever waste you create, you have to use it there itself. So this is the criteria that is coming. That means you have to recycle and reuse them. Nothing, you cannot take it out and make it somebody else's burden. So this is another issue that we have to look at it. Emissions is another example. Issue we have to look at it when we use greenhouse gases. So a whole lot of them we use during the operational life of it. But the issue I want to highlight here is that it is not during the construction that we create energy. Actually, it is during the operations. If you take a single family dwelling, you can see if you during the production, if you have created 1.7 tons, during the service life, we use almost 200. So, and still civil engineers are blamed for the environment degradation. If you look at a 5-story residential building, we will use that construction time and the operation during the service life. It is much more emissions do happen. Unnecessarily, civil engineers are blamed for this one. CO2 emission is one of the biggest problem, which is they always say it is false. or the whole reason for the climate change, and you can use it. India is very low, very, very low as far as this CO2 emissions are concerned, but we do agree every year to reduce it by a certain percentages. And if you take the per capita such emissions, we are very, very minuscule, but still any emission, I don't think we can geographically divide the environment for India and USA or Pakistan. The environment is all ours. Each of us belong to one environment. We can't partition and live in a particular parcel. So that is the idea. So if you look at the holistic approach, what we are supposed to do, basically we should look at safety. Safety in terms of a whole lot of safety, structural safety, from fire safety, every kind of safety, life safety. Safety is one issue, and durability and serviceability, that whatever we construct can be utilized throughout its service life with minimal maintenance, minimal interventions, and feasibility, economic feasibility. Whatever we do, 100 rupees things, can it be done at 90 rupees? This should be the question that we have to challenge, and we have to find answers, and then see that whatever we create are environmentally compatible. Don't create a issue which will continue to create a problem for the environment. And then we have a tremendous amount of social responsibility as civil engineers. Sometimes we forget it. I will always quote a example that when we ride on a bridge, ride on a flyover, ride on any civil engineering facility, nobody is going to ask the question, who built it? They know that once a civil engineer built it, nothing will happen. It will not fail. So this is the kind of confidence the society puts on us, and we have to rise up to that standard and see that the trust they put on us is given it back to them. So this is the idea. So we are a people who are tremendous responsibility to the society, because all of them sleep in buildings, all of them travel on roads, and all of them trust civil engineers so that they continue with their life. So that responsibility is huge on our shoulders, and we give it back. Exactly, the trust should not be any time betrayed. So this is the idea. So if you look at the sustainability, basically there are three parameters. Economy is one thing. We can't do issue. I mean, we can do many things if you don't have any constraint of economy, and environmental challenges and social development. All these three parameters should be in our mind. I mean, when we do the whole of our realm of activities. So the core should be to see that whatever activity we do, we should be with all these three basic parameters in mind, and we will be able to do it. So basically, sustainability action should be reduce the life cycle cost by improving service life. That means increase the life, reduce waste, reuse them, and recycle them. So this is the idea based on which we create the sustainability regime. So this is the idea. So if you look at the life cycle of a particular process, we extract new material, we design and produce, and we do the construction, and then we use that process, we use that facility, maintain them, and then what we do is we send them for reuse and recycling. After recycling it again, it comes back. So the cycle should be on and on. Never go to extract a new material for the next construction. Can we reach that stage? The ultimate aim should be to see that our extraction of the raw material from the mother earth should be reduced and reduced and reduced. So if you want to redo something or a new project, how much of those material which is already being used can be effectively used in our construction? This is what we should look at. And our problem as well as an advantage that we got is a huge population. We have a population, we are going to overtake China in 2040, maybe earlier. We are going to be a 1.45 billion in 2040. We will be the most populous nation in the world. And naturally, each one of this person belonging to that populous country, nation, India, will require infrastructure, will require a place to live. We have to commute. So the kind of responsibility on us, the kind of instruction that we have to do to satisfy and improve the quality of life of all those people in the coming years is tremendous. So this should be kept in mind when we plan and act in the next coming years. So we should, how do we manage this issue? Economic sustainability part of it, out of the city circles, the financial soundness of everything that we are responsible, because nobody else is responsible. We are the only people who know the design. So we are only the people who do the construction processes. So we are responsible to see that whatever we do is financially sound. And we have to do a cost benefit analysis. We have to create various alternatives and find out which is the most cost effective project, cost effective methodology, cost effective process that we are going to do it. For which, at the same time, we cannot cut corners with the performance standards. If someone has to use a facility, that performance which is indicated right in the beginning cannot be cut to reduce the cost. And then the service quality also we cannot compromise. And then adaptability, that whatever facility we create should be, the user should be able to adapt to that particular, create whatever we have created. And that is the management thing. Social sustainability is, as I on the other circle, the social sustainability is also whatever we produce. If it is not enjoyed by the user, what are we doing? For whom are we working? So this is the question that we should ask. We should look at their health and hygiene. Are they able to use the facility with proper hygiene? And their health is in any kind of threat. And safety of the users, safety during construction. What about the security in terms of earthquake? Safety in terms of earthquake, it can be a flood, it can be lightning. There are so many things that we have to take care and bring in when we do our work. Labor rights protection is only engineer, and the engineer is concerned with the labor rights. We are supposed to see that the people who work for us, the workers, are to be looked after carefully. I mean, this is one of the major responsibility. Many times we fail, I must admit, but this is the basic responsibility given to us to look after the people who work for us. And then is the training, education, and growth. We have to bring out the next generation. So we have to do a lot of research, and research has to be transferred to the students, the future civil engineers, and then train them and train them and train them so that they can be doing better than the last generation of engineers, which contribute to the growth, the future growth. And then we should look at the equal opportunity. That is everybody, every part, every small, big, every economic, the levels they come from, there should not be any kind of discrimination in terms of language, in terms of religion, in terms of sex, in terms of anything. There should not be equal opportunity shall be given to each one of them. And then we should also see that the stakeholders participate in our decision making. Many times we do clients for whom we are working, the stakeholder may not be an active participant in your decision making. Then the basic thing, ultimately, it is the integrity and the ethical behavior. Many times we are challenged by the general public, the media, and the management on this particular issue. In fact, I must confess that we ourselves have given a kind of image. When it comes to integrity, we are often not able to stand up and question this put to us by the society. I don't know where we have gone wrong. I think the education and training towards integrity and ethical behavior should start on the very first year of our academic program. That as civil engineers, we have a huge area to cover when it comes to integrity and ethical behavior. And privacy and dignity is another thing, that whatever work we do, we should make sure that we don't hurt anybody's dignity, and we also do not violate anybody's privacy. So this is also an important issue. You would have come across, senior engineers would have come across occasions in which we hurt a whole lot of people for getting things done. But that is not what an actual engineer is supposed to do. So this is when it comes to the social responsibility that we are supposed to do. And what are the tools and techniques available for this one? For achieving all those things, we have to benchmark. So this is one way of doing it. We benchmark and we keep on improving our benchmark so that our construction management processes are improved after every day. We give challenging benchmarks and try achieving them. then take risks. I mean, you can't avoid risk when you do any particular process, any part of our life. Every human activity has got a part of risk, but then it's possible to analyze it, and from past experience we can forecast it. I mean, this is the day of artificial intelligence, and it is possible with the huge amount of data with us, we can always find out what are the risks involved, and we can be a step ahead of those risks, so that when the risk comes, we are ready to challenge it, we are ready to overcome it, and we should be able to forecast that. So this is why whole lot of data has to be gathered, analyzed, and kept ready, so that we know what are the risks that are going to come and in future, so that we are future ready to challenge all those risks. Then this environmental descriptors, I mean, you can actually compartmentalize them into various parameters. We'll come to that a little later. Each one of those descriptors can be taken up, and each one of those descriptors can be programmed. A plan can be prepared to follow all those descriptors and see that those things are managed, those things are achieved, those things are not violated. If you do a good work on that one, compensate him. If he does bad work, improve him by training. So these kind of descriptors are to be created for each project as we grow. And then the failure mode analysis. In fact, our failure has come somehow in civil engineering. This is a whole lot of issue happens when it comes to failure. We don't accept failure. Our idea is to immediately sweep it under the carpet. In fact, this is an excellent opportunity for all of us to understand how that failure has happened. But this kind of a study never comes up, because we are all eager to camouflage it and get ahead with this one. A failure is an excellent opportunity to see what exactly has happened, so that it doesn't happen in future. Social impact assessment, now it is compulsory that in each of the projects that we do, but unfortunately this kind of training is not available in our academic programs. So what is required is training. To create, or anybody should do that kind of a social impact assessment training to all those people, that when we travel, when we do our work, how much we create nuisance we create to the general public, and see that, and how much people we hurt in our process, and see that we are able to see we have a particular mechanism to understand that and learn from this one, so that it doesn't happen. Then disaster is another issue, as I already mentioned. We have to analyze them, and we have to take steps, so that in case of a particular disaster, how to do it. But often multi-disaster takes place. When a huge flood comes, it can be a landslide plus flood. There are so many things happen together. So are we ready? Do we have the blue book to look after? For example, when Corona came, Kerala was fortunate that we were ready with our procedures. We were ready with our SOPs because of NEPA. With the WHO, we were able to create processes and procedures which has to be taken, and things which are to be kept ready in case a disaster has to be faced. So this is another issue that we look at it, so that when a disaster comes, we are ready to face it, and we got the wherewithal, we got the trained people, we got the material to take care of those situations. So this is another idea. So at the procurement stage, we should have the policies available. So from where we should procure each one of them, and what are the selection process? If you got 1, 2, 3, 4 options, which one you select? You should be able to do it. For which huge data is required to collect data, so that we should be able to create systems, and we can select. And then contracts and liability safeguards should be in place for the requirements, the procurement stage. We have to create systems for that. During the construction stage, we have to look at the constructional practices and look at where we are, because this is our bread and butter. So we'll have to look at where all we can improve, where all we can cut down, where all we can create efficiency. At the same time, look at safety and health. Also look at the environment. So this should be seen at the construction stage. A typical environment monitoring system, which I have done in one of the projects, but it has to come to the construction process. Typical parameters: look at the ambient air quality, test groundwater quality, and noise levels. Each site we put in our agreement that before you start the project, all these parameters should be tested. And we wanted an external agency to audit it also. So in each of the project, 10 or 15 projects that we have done in Kerala, we created these parameters what is the ambient air quality existed before the contractor came to the site. And every year, 3 times a year, some of them even shorter intervals, you continuously do the monitoring of these parameters. And if the base safe parameters are violated, take action. I mean, he has to bring it back or take punishing action by fining or ask him to compensate or anything like that. And when he leaves, what are those parameters? Are we still sticking to those parameters? These kind of environmental monitoring should come part of the tender the agreements, tender documents as well as agreements. These are only examples of very free ambient air quality, ground air quality, and noise level. There are any number of such descriptors we can create so that the environment is not damaged. We can really measure, and we can also give marks to the contractor who has done a job. If he had come in and left exactly the way, you give him good marks, and when you qualify him for the next project, that should become a criteria. These are the areas in which we should improve our construction processes. And stakeholders, we have a lot of obligations to the client. Not only that is with the money, but we have the product should be, I mean, you should get a matching product also. Then the contractors, are we, I mean, when a contractor comes to you, when he goes away from you, how much better he is in terms of so many parameters. His construction processes, his construction equipment, his efficiency, what about the health of his labor, and what about his own integrity when he leaves you. So these are certain parameters you should see, that when a contractor comes and goes from you, has he improved? So this is, as an engineer, we should look at it. Similarly, small vendors and consultants, what are the responsibilities that he has to do? And project management, as project managers, what are our responsibilities? Which are the areas, key points in which he has to look and see that the stakeholders are similarly public welfare. This ultimately, this is the, if the public is not satisfied, and every time public looks back and criticizes, our whole effort, what we have done in the last 1 year, 2 year, 3 year, will be of no use. So ultimately, it is the public welfare. To that extent, civil engineers often fail. We do not know how to communicate. We do not know how to manage the media. And this is extremely important in a place and a time we live, that we have to communicate. Now there are so many means of communication. The social media is increasingly important. I will not say weapon, a tool that you have got, but we are still unable to communicate. This is again a training that we have to acquire when we get trained in the colleges, in the academic institutions itself. So communication is the key. Are we able to communicate with the client? Are we able to communicate with the contractors, consultants, project managers, as well as the public? So this is an issue on which we have to agitate, and who have to do a lot of work in managing the media and the social networks. So this is an issue on which we have to look at it. We also have a document we have prepared. I don't know how many of you have seen the National Building Code, the recent National Building Code. We have added a separate chapter, part 11, approach to sustainability. Now this is a standalone, it is not a standalone chapter. This only gives an approach to the whole thing. This covers the entire work that is prescribed in the National Building Code. So it gives certain way how to approach sustainability in each one of those activities of built environment development. That's the idea. So it looks at the need for sustainable development. What are the elements of sustainability? What are the life cycle sustenance? What are the technology options? Energy efficient design and processes, reduced and embodied and operational energies, integrated water management, operation and maintenance of services, monitoring compliances, corporate governance, and disaster preparedness. So these are the areas in which the chapter looks into. Each one of them are giving guidance or approaches to all the activities hitherto mentioned in the other 10 parts. So this is what we have brought it in the National Building Code of India, which has been published recently. So that's where we are. So if you look at the need for sustainable development, we already know in the building construction, occupancy, additional alterations, preventive and remedial maintenance, all these elements will have to come on. And we have to look at energy and material intensive. These are all energy consumption. These are all material intensive, and a large amount of primary form of natural materials, water, air, energy, etc., are consumed. And so that we look at the project life cycle. So this is one issue. Life cycle design is another issue, but we have to look at and analyze this one. That is the planning and design stage, then construction management processes. So these are the issues in which we have to focus and see that the elements of sustainability comes in each one of them. When we select a site, what is the form we have selected, and the design that we evolved, and external development and landscaping, and the envelope optimization, materials, water and waste management, building services optimization. This is what the National Building Code has given. So each one of these chapters are further explained: siting, form and design, what we are supposed to look at, and the energy, what are the energy we have to look at: the embodied energy, recurring operation energy, refurbishment energy, as well as end of life disposal. These are the areas in we look at it. So for all these parameters and descriptors that you have mentioned, I am taking one material which we use for in our practice, what is the concrete. So if you look at the concrete, it is one of the most widely used construction material. So generally it is said that only next to the water consumption, per capita consumption of concrete is only next to the water, which is a fact. So it has got impact on all economic activities. And the GDP, I mean, it varies from state to, I mean, country to country. It has got a huge contribution to the national development. At the same time, we are blamed that the material also damages the environment, because it is easy to produce, material is available locally, we overuse them. This is the complaint. So there is a lot of advantage to this concrete, because practically the world creates almost a Himalaya or more than that one. It is mentioned that you are creating almost 1 kilometer. If you take the footprint of 1 kilometer by 1 kilometer, the height of the cube will be almost the height of the Everest. So this is the kind of concrete we produce every year. It is not just total. So that is the one. So you can see the huge quantum of material and how much of natural resources go every year. We take it out of Mother Earth and use it. So this is why, because this is one of the most economical use and it is locally available. Not a great skill, rocket science is involved in making and producing concrete. So what has happened is, this is so simple that we neglect it. This is what has happened to the concrete, and it has created problem for concrete. So when we created and working on the concrete, how did we start? First, we looked at only safety. Safety was our, up to 19, if you see that 1970 or that area, the code was concerned with safety. That is all. But then what has happened is, after independence, we have constructed a lot of structures, lot of development, and by 1970 and 80, we have seen that whole lot of such new construction has started deteriorating. So then we knew that there is something wrong. So the whole, all of us look back to see what has really happened. So a new chapter has come in the IS 456 on durability. That was the first time durability was made important, and now durability part is growing. And that part will be one of the most important part. Of course, safety, the building should stand, but durability has become equally important. And then the serviceability. During the life cycle, the construction should continue to be servicing the clients. So this is another issue. And now we are going to look at each of our activity in terms of sustainability also. That is the new parameters which has come in the code. And if you see the new development that is coming up, sustainability will be one of the important. So this is the stages of development our codes and our profession has developed. From safety we came to durability, and then serviceability. Now sustainability has also come, and this is also becoming part of the code. You've seen the National Building Code has already started a chapter to bring our focus on this one. So if you use the cement production, you will see that our whole world production, China is using almost more than half the production of cement in the whole world. But next to that, we are growing. We are India, but we are only 6 or 7%, whereas China is something like 55%. So, but you can see as we grow up, because we have a lot of work to do in terms of infrastructure development, we will be consuming much more cement in future and much more concrete in future. So the cement consumption is growing. I have mentioned that by 2050 it's supposed to be 4 billion is a projection, maybe more. And in India also we got a huge capacity. We are growing in terms of that also, but still we are very low when it comes to per capita consumption of concrete when come to cement when compared to other parts of the world. One of the major problem issue that we are facing is that most of the concrete that we are produced in this country is in the field and not by very high tech procedures and high tech plants. This is one issue. In fact, we look at the ready-mix consumption is extremely small. When we use very little of precast concrete, and our plant mixing itself is very low. And when it comes to RMC, it is still low. However much we are trying to bring in that concept, it is still not reached. So this is one way of improving the quality and sustainability, is to improve the quality of the plant and improve the quality of the processes and improve the quality of the concrete. So this is the best ways to do. The route is to centralize, use good plants, use good people to produce good concrete and lay them. So this is one activity that we have to bring in. The certification of the RMC has started recently, and the Quality Council of India started. Now BA has also started certifying based on the ISO. I hope that this will catch up, and it is highly necessary now that we insist that the concrete produced in this country, the plants and the RMC are certified. Till the time that kind of regime comes, we can do very little when it comes to quality of concrete produced, and naturally the durability of such construction using such concrete will not be much. So if you want to achieve reduction in use of material, one way would be to look at the quality of the concrete that we produce, so that the structures that we create last longer. So this is one thing. So the life cycle cost is an issue that we have to look at it. We don't just look at the cost on that part only. We have to look at many other parameters, so that we look at the life cycle cost of a project, not just the cost of the concrete or cost of the aggregate. So the low investment and initial cost often require higher cost of maintenance and repair. We should not forget about that one. That is why it is extremely necessary that we look at the life cycle cost. That even if you input a little cost now, can we reduce the cost of maintenance and increase the life of the service life of that particular structure? This is the way we have to analyze it. So the life cycle analysis is ISO 14040 has already brought in a very good way. I mean, it's not exactly a formula, but they have got a methodology in which we can really assess life cycle assessment. ISO 14040, that is the raw material acquisition, the production, the use, end of life treatment, recycling, and final disposal. You look at each one of them, and in fact, these are all excellent material for presentations later. Somebody can take it up and do presentations on this issue. How do we do using this particular code? But it is a very doable code. I mean, people can do it. For example, sustainable design, you can look at different designs. Column itself, we take it, what is the size, by increasing the cover, what happens, how much of CO2 we can reduce, and how much of concrete we can reduce. So that kind of studies we have to do. So by doing a structure which can withstand the time, can you reduce the CO2? So ultimately, the environmental design should look at the minimum CO2 produced every year. If you look at, can we create structures like that one? Even the size, the cover, the kind of material, can we use stainless steel, which will increase the life? Can we use, say, stainless steel cladding? Of course, it's costly, but then we have to look at what are we achieving? If we put a price of CO2 emissions, if damage, then we will be able to work out. This is the ideas in which that particular code is thinking, that each one of our design process, each one of our material use, each one of our construction methodology, look at how much of CO2 we are going to give it to the environment. So if you are able to minimize it, that is the best design. That is the way they will look at it. So this is one issue on which we have to study. So we should look at all those things as per that code. What is the embodied energy of each mineral extraction, processing, transportation, mixing, placing? You can add each one of those processes, how much CO2 is coming. And generally, production of 1 ton of cement releases 1 ton of CO2. You can reduce it. I mean, some of the technologies have come. We are able to do as low as 400 to 450 kg per ton. It is possible to improve. That is one way. But during the design, life cycle design, we have to look at each one of these parameters. And we know that each one of them, how much CO2, cement, how much, admixture, how much, reinforcement, finishes, aggregate, production, processes, transport, whole lot of parameters you have to keep on, I mean, for which a huge amount of data is required. And you are able to create a matrix, and you can do the design so that ultimately, after the end use, how much CO2 you are going to emit as emission to the environment. Oh, so the minimal the emission is, that is the best design. That is the way the environment design can be done as per the code. And then we should use alternate fuels. I'm not going to go through the whole thing. For production of cement, there are a whole lot of materials now alternate available. And we are also bringing new types of cement base, cement binders, which is not cement based. There is a whole lot of them. But then we can also use many waste material in the as replacement to the cement. We'll look at it. And so the this is just repetition. So locally available materials, we should use them. It has to be used because otherwise the transportation energy will be much more. Then salvage, refurnished or remanufactured includes saving of material from disposal. That means so a lot of, this is required for innovating, repairing, restoring, generally improving the whole lot of activities we are doing. And reusable and recyclable materials are available, which we can use them. So recycled demolition waste aggregate is one issue which is coming into the fore, and recycled concrete aggregate, blast furnace slag, manufactured sand, glass aggregate, fly ash. There are a whole lot of new material from the waste side which is coming into the cement production. So this is the way we should look at it, so that the natural resource we are reducing, and also we are saving from the side of the waste utilization. So together we are able to make the environment design better. So we reduce the natural resources, and we also reuse the waste waste products from other processes, and we improve the environment. This is the basis of the design. So a scientific approach to concrete design, optimization in particle, you can design, mixed design itself offers us a huge opportunity. We have not gone that deep into the mixed design earlier. Now, after the iterations, modeling has been done, a whole lot of people are getting into the inside the concrete to see what exactly is happening. So there are a whole lot of way in which we can improve the mixed design. So optimize the void space between aggregates, and a whole lot of methods, processes are available. So we should be able to use the least amount of cement, which will reduce a whole lot of other problems of concrete. So this is the way we should look at it. More the cement, the more shrinkage, and naturally it will create more cracking. So the idea should be to reduce the cement to the most efficient use of cement only. So less cement will naturally create less heat of hydration, so less cracking inside, so less porosity to the concrete. This is the idea. So this is what we look at it, that can we design a concrete optimum proportions so that we get the best strength out of the mixed design itself. So this is a process which is happening in a number of laboratories across the world. How to create a mixed design, we were doing just in the laboratory. We are doing by repetition, but there are a whole lot of other methods by which mixed design can improve. So the properties can be improved. The mix, we look at the paste volume itself. There are a whole lot of methods available. So we get higher strength of concrete per kilogram of cement used, durability and lower permeability, because if you use the least cement, we will get the best non-permeability. So that is the way. That means the durability is improved. More aggregate means higher modulus of elasticity. So there are a whole number of parameters we have to create and study, so that we create the best mix design. So this is the activity which is going on. So the advantages would be it should be user friendly. I mean, we should be able to use it. Whatever mix we produce should be useful. It means easier handling. That means it should be able to handle easily. Better consistency, very good finish it should give. Shrinkage and creep should reduce. That is we call it the green concrete because we have used a lot of waste material and recycled material into the concrete. The heat of hydration is significantly less. So this results in lower temperature rise in the large concrete pours, which is a distinct advantage to the green concrete. So a green concrete, the concept is still not yet there, but we are reaching there, that we reduce the quantity of cement, use more waste material into this one, and do a better sophisticated mix design to produce a concrete which is durable, which will give you easy to use, easy to produce. So this is the whole idea. So looking at increasing the proportion of waste material that are pozzolanic, we have got a whole lot of material which are available. This will also reduce the heat of hydration and less cracking, as we already discussed. So the net emissions from the manufacturer, this is another issue. There are many ways of avoiding the CO2 getting into the field by CO2 capture. I'm not getting into the higher technology which is being developed, including the algae bioreactor. So that is one thing. The other way is the direct approach that improve more efficient cement production, use of alternate fuels, and carbon capture and storage. So and other things that is happening. Sequester CO2 generated by cement kilns. There are so a lot of methods in which they directly take the CO2, what is produced, and bury them forever. So this is another thing. This is another activity which is going on. Then eco cements are coming, which is having less CO2 production. Then materials that are non-fossil carbon, that is another issue. Many such materials are coming. Then technologies that introduce new properties are coming. There are a whole lot of things that is reducing the lifetime energy, that reduces the conductance, that increases the specific heat capacity, reduce weight strength ratio. This is the basic study which is going on everywhere. Organic fibers and fillers are used for this purpose. That can, many of them can be the waste which is coming from other industries, and that improve the durability. So this is another thing. So if you look at the durability, is one of the parameters that we have discussed so far. What exactly is durability? It is the concrete durability of the concrete is defined as its ability to resist weathering action, chemical attack, abrasion, or any other process of deterioration during the entire life cycle. So if you look at the 456, it mentions a durable concrete is one that performs satisfactorily in the working environment during its anticipated exposure conditions during its service life. A durable concrete will retain its original form, adequate quality, and serviceability when exposed to its environment. So this is another thing. So there are basically two systems on which we are looking at: the concrete system and the service environment. The concrete, we look at the materials and the processing, and in the environment, where exactly is placed there. So the code itself gives certain classes of environment in which the concrete is working, and gives certain prescriptive parameters to be used when the concrete is, the structure is placed in certain service environments. So that is the other thing. So look at it. We also, what is happening here is, many people say that the older structures survive and the new structures are difficult to manage. The deterioration is more in the modern structures, or the structures which has been done recently. The problem is some kind of ignorance is happening. That is because it is not the same cement that we used in the olden times that we are using today. The cement has changed its properties. The cement has totally changed from an earlier age to this age. But that communication is still with the cement producers, but it has not come to the professionals who use them in the field, the people who use the mix design, the people who use construction processes. And this is an unfortunate situation. So what happened is we are today looking at early grain strength. This is what we want because we want to de-shutter fast and finish the work as fast as possible. So speed has become an important parameter in construction, and the cement uh, manufacturers are helping it by producing cements which can gain strength faster. So what do? The process is they increase the much higher C3S and C3A contents are coming here, and the fineness of cement has also increased. It is fine, it is excellent, but the people who design the mix, the people who use the processes also should understand this what's happening here and do the design. So the change in design is required. With the change in the cement character, it is now possible to achieve design strength with lower cement content. It's excellent, and water cement ratios. Earlier, if you are able to produce a 35 grade concrete with 350 kg, today it is possible to produce a 250 kg. It is possible to do with proper mix design. But then these changes characteristic, what happened is the change in cement characteristics also we should take care. The heat of hydration is increased in peak temperature, and because it occurs very early, so microcracking starts, and naturally that lead to deterioration. So that what happens is, if it happens, it is a very slow process to heal. Unfortunately, our construction practices, especially in handling, placing, compacting, and curing, have not kept pace with these changes. So it is extremely necessary to create that bridging between the development in the cement production and the practices in the field. We should create communication between the two and create processes and procedures, SOPs, to do this one. So what are the factors affecting durability? The porosity and permeability, which is coming out of a whole lot of reasons. These characteristics like water cement ratio, type of cement and aggregate, as well as presence of crack. These are the one that happens. So the mechanisms: corrosion of steel, alkali aggregate, ASR we call it, and then the carbonation, chloride attack, sulfate attack, seawater attack, delayed etching formations, freezing and thawing. These are all available in the code, and only thing is that, like environment, we also have to plan. Durability planning is required. Planning for exposure and environment. Find out where it is put and have a plan. What should be done? Planning for material selection. Right at the beginning, we should select proper material and see that the durability is assured. Planning for construction processes. So as I mentioned earlier, the construction process have to change to suit the cement quality or the type of cement that is coming to the market. And planning for on-site testing, continuous testing, such things should be there. And acceptance criteria and durability parameters should come into this one. We are just looking at strength only today. Durability parameters should become an equal partner with us, so that we are able to test it in the field and certify. So this is the changes that we allow to happen. So these are certain new development. It starts from belite cements to geopolymers. Geopolymers are slowly coming into the market. Declaration and labeling is an issue which has happened. A lot of advanced countries it has happened. The marking is done, the labeling is done. Just like the mark, there is a label can be given to the cement, which will give you the least environment damaging. So such things are happening slowly. The international standards have already started a code production. A code is under preparation, almost finalized for declaration and labeling. In fact, South Korea is already using it. Japan, to a great extent, started using. Many other countries are using that. When you look at a cement bag, you know what is the mark given, environment marking, which has been given on the bag, and use them. So if type 1, that it means all the defined criteria in 14,021. And self-declaration system is the type 2, that without any third-party evaluation. And type 3 system based on birth to grave evaluation by a third-party ISO 1404043. So there are many types of labeling and declaration can be done. If you look at the aggregate, both aggregate golds and fine are difficult to get now. So what we have to do is we have to start reducing the use of that one, because there's no other technologies available. But there are a whole lot of new promising materials are coming. Sintered fly ash is already, it has come. And we are also using a lot of other new material which has come, which has been incorporated in IS 383. which will reduce the use of the naturally occurring aggregates. Then recycling of construction waste is another option. A pilot plant is already in operation in Delhi, more than one. Now there are two. I'm very sure that it should come into other parts of the country also. The IS 383 has already incorporated use of recycled aggregate in the construction. And the Sindet plant is already, one is operating in Odisha, if I'm not mistaken. One more is in the Anvil. I hope that that produce will start coming to the field also. Aggregate from waste, fly ash as fine aggregate, the code permits it. And now studies are going on to use pond ash also. Cindered fly ash, as I mentioned, already come. Manufactured sand is permitted. Copper slag as fine aggregate is permitted in the code. LD slag as fine aggregate is permitted. Blast furnace slag as fine aggregate is permitted. Iron and steel aggregate fine aggregate is permitted. Now C&D waste as recycled aggregate RC or recycled concrete aggregate, both are permitted, but not in a full extent, but certain percentage can be used. Yeah, another 15 minutes. So this is the kind of demolition material that come, when we see at the site, but it can be taken to the field. This is a Delhi plant which has been put up by the municipal corporation. Another is also come in the eastern side, which has been recycled into, you can see different sized aggregates. This is the site where it has been recycled and kept. So at present, we have two types as per the code 383, RCA or the recycled concrete aggregate. This is predominantly from concrete waste, and recycled aggregate, which is from all kinds of waste, including masonry and asphalt. So leftover concrete aggregate is also there, that is used for very, very minor works. Areas of application after proper processing, it can be used for structural grade concrete. We can use up to certain restrictions and percentages are there. New concrete for pavements, shoulders, median. This can be used in precast elements and used in the pavements. Lean concrete bases, it can be used. Bituminous concrete and soil cement pavement bases can be used. Code permits them. The aggregates from bulk volume of concrete, IS 383 provides for aggregate specifications. Mostly aggregates are derived from, this recycled aggregate is, you have to do the testing. But one of the major problem is the paste aggregate. However much we clean the aggregate, some paste remain. So that is why we are not allowing full percentage. We are allowing a much smaller percentage. The British standards are allowing 30% more. But in the Japanese, they are using a whole lot of higher percentage of aggregate, but because their processing procedures are quite different. Other mineral admixtures what we do as replacement of cement is fly ash, silica fume, finely ground slag, ground grass granulated GGBS, rice husk, metakaolin, and limestone powder. Whole lot of materials are coming. Then we are also come to use whole lot of construction chemicals. This is one of the most exciting field. That is properly we are cooking concrete. You give the parameters that you want, and they can be produced by using proper construction chemical. And our industry is also responding. Whole lot of new materials has come. Chemical admixture as retarders, water reducing agents, superplasticizers, shrinkage reducing admixtures, repair and rehabilitation materials, whole lot of them. Corrosion inhibitors, waterproofing materials, curing compound, shortcut admixtures, floor finishes, sealants, adhesives, like that one. The whole industry is growing. I think it's one of the fastest growing industry in the construction industry today. And a whole lot of new materials are also coming to the field. The other exciting field is the fibers we are using. It's available in this country. We are asbestos, carbon, aramid, glass, polypropylene, polyamide, polyester, nylon rayon, polyvinyl alcohol, polycryl nitride, polyethylene pulp oriented, high oriented polyethylene, rock wool, carbon steel, stainless steel, alkali resistance. Whole lot of fibers are now available, but some of them are yet not popular because they have got specific uses. The designer should know it depending on the performance criteria and use them in that one. This is another interesting field, the polymer concrete, and latex modified concrete, and polymer impregnated concrete. These are also seldom used, but it will become practical very soon. Ready-mix concrete is the one we should encourage, and this is one way of one road to quality, improve the quality of construction in this country, because it is the easiest way to penetrate new technologies into the concrete production and use, because an average consumer doesn't know how to produce concrete properly and how to test and accept it. So, but this is the best way. But only thing is they should be certified, and they should also use technology and technologists who are qualified to do this job. So we are nowhere in this country. We are not even 15% the concrete is through this particular route. But an effort should be made by the industry and the professionals to use that. More and more RMC is used in construction. So some of the places where we have used concrete is this to produce most all of them. We have used RMC concrete. This is some of the surface finishes we got through use of concrete. And what are the other advances? What is happening in the construction technology? Lightweight concrete is coming. The code is now coming up with the lightweight concrete permitting. Heavyweight concrete, where we have to use iron ore or such material where because we use the derivate, that anchor, we have to get heavyweight concrete. Many applications are there. High strength concrete. Now the concrete is permitted up to 100. We are going to 120 very soon. High performance concrete, depending upon what exactly you want, you can cook your concrete. Fiber reinforced concrete, self-compacting concrete. This is going to be the order of the day very soon, because the tremendous advantage that this particular material possesses. Roller compacted concrete, concrete containing polymer, decorative concrete, and porous concrete. We'll have just run through the whole thing. High performance concrete is a special combination of performance. What performance you need and uniformity requirements that cannot always be achieved by routinely through normal concrete. This is the whole idea. So that you prescribe a performance and strive towards getting that performance through. This is the whole idea. And it can be, one of the parameters can be high impermeability, high strength, another can be high strength, high elastic modulus like roads and other things, low thermal strain, low drying shrinkage, low creep. You can prescribe your parameters and you can get what you want. So this is the idea. And self-compacting concrete assets in exciting field, and where we should be able to go very soon, because many of the advanced countries use this very often because of the tremendous advantage and tremendous quality that it can produce. We had one of the projects I was involved, the signature project itself. This is the kind of reinforcement available, and each pier is almost 9 meter plus high, and we wanted to do it in a single pour. Normally we calculated this would have taken about 18 to 20 hours of pour, whereas we went for using self-compacting concrete, such congested concrete, we are able to finish the entire pouring in 1.5 hours. That's all. So that is the kind of advantage this particular material possesses, and it is necessary that we try. We can pour 9 meter in one single pour without any segregation, and the kind of quality just behind the pier, you can have a look at it, what is the kind of quality we get. Of course, it requires preparation, it requires the very, very keen design of the shuttering and very, very tight temperature control. There are so many things, but the product is excellent. I don't think anybody can pour 9 meter without a proper system, but the quality and the time saving, from practically 2 days of preparation, we could finish the whole pouring in 1.5 hours. So that is the kind of saving. So the people have understood elsewhere in the other countries, and they have already moved towards using this one. In some of the advanced countries now, almost 50 to 60% concreting is done by this route. See, this is the kind of reinforcement we have had. So I am not going into this one. It is concrete which flows under its own weight without any segregation. At the same time, maintain homogeneity. No vibration is required. It can go into any circumstances, any particular situations. That's the idea. The advantages are faster construction, reduction in site manpower, better surface finish, easier placing, improved durability, greater freedom in design. You can have shapes that you cannot even imagine. Thinner concrete sections, reduced noise levels, absence of vibration, safer working environment. So much of advantages are there. I think we should soon change into this particular area. The basic ingredients exactly remain same, except the VMA, that is the viscosity modified admixture. That is the only additional thing that is required here. Of course, proper design and proper supervision is a must. And this is a kind of concrete you can, I mean, this is the slump test that we call it. The concrete spread almost like a dosha, and you measure the diameter. If it is able to measure 500 millimeter, you are successful. So that is the kind of concrete that you produce. There's no segregation, you can see from the picture. So the another interesting area is the high volume concrete. We have used few places in creating some roads, but we have not caught up with this particular technology. But this is also an excellent field, excellent area in which we can develop it. We have done some, I mean, there are many places it has been done. Other areas in the US it has been done, but somehow in India it has not caught up yet, except some few roads which has been done. Porous pavement is another issue, another area in which we can develop, because one of the major area is, in case of sustainability, is the water is available. If you are the entire water, if you allow to run off, this is a very dangerous thing. That's what we do. Most of the places when we create areas, we concrete the whole place, and entire water, surface water, pours into the roads, and from the roads to drains, and it blocks the entire city. This is the idea. The idea of using porous concrete is to see that the water doesn't flow, it goes down. So this is practically a no fines concrete. This is the way the concrete, we pour the water, the entire water goes down. It can easily be used for parking areas in Delhi and other places. We have tried somewhere. It's quite successful. You can see pervious concrete and the asphalt at the same time. After the rains, the water remains there. In the pervious concrete, it's not even a drop of water immediately after the rain. It's purely dry. So this is the kind of surfaces we can create. Decorative concrete is another issue, because most of the concrete we overlay with other materials like marble and other things to create surfaces. Can't be used concrete itself as an aesthetic enhancement. By many methodologies available, by polishing, by using dyes and other things. So you can use stamped concrete, you can use dyes, you can acid staining, you can do water-based staining, you can do overlaying by polymer cement overlays. There are also epoxy coating, polishing, engraving, foam liner. You can surfaces. There are many ways of doing it. I mean, this is a typical concrete ground and polish. It looks excellent. It looks like granite. So what we do is we provide a concrete surface and use granite cladding. In fact, if you are able to produce the concrete itself as granite, we are going to save a whole lot of resources. You have to use a granite material to give finish to the concrete. So this is the idea. Concrete itself can be created by grinding and polishing. And there are several technologies using dyes, create patterns like this. This is pure concrete, nothing much. It is only dyed, polished, ground, and polished. That's all. You can create decorative concretes like this using liners. I mean, a whole lot of liners. You can give your design, and liners they can produce and create concrete. This is available. We have done in Delhi. These surfaces we have created in Delhi for a project, and it is beautiful. So what is the future for all of us? The development is happening. Development is happening, but only development starts walking from one place to another. 10,000 years ago, it was in the Mediterranean area. 2,000 years ago in Rome. 1,000 years ago, it is all hidden in the religious text. 200 years ago, it was in England. 100 years ago among Europe and US. The future is expected to be in Asia, among Japan, China, and India. So China is already #1 in all kinds of activities, and we are catching up. Very soon we will catch up, because our requirements are huge and our aspirations are bigger. I hope that we will be able to reach. We will capture the future very fast. So conclusion is, concrete is very old, but at the same time, even today we are not understood it fully. The developments will continue to make the concrete as useful as always been. Concrete will play a major role in improving the quality of life of the people in the years to come. Its contribution will continue to be significant in the social development of the humankind. So with that, I'm concluding from my part. I will leave to the audience if you have any questions. Mr. Kaushik? Mr. Kaushik, are you with
Yes,
us?
sir. Yes, sir. Yes, sir.
I have concluded my talk part. Now you can take over.
Sir, some of the questions asked, I'll just tell one or two questions actually.
Mhm.
One of the questions,
Yes.
Can I see it on the screen?
one of the,
Okay, I'll make the attendance. Organs. Hello.
Yep.
Now you can see the question, sir.
are-
Not yet come. Murali?
we will read out, sir. Can we read out one or two questions?
It's not coming on the field on the screen.
No, sir, it's below the polls.
Below the
Yes, sir, but only one question is there.
Can you see question? Yep.
Hello.
No, even that is not clear.
Can we read out, Abin?
Yeah,
Are you able to
yeah.
read
Please do.
read out one of the questions actually?
Yeah, please do.
What are specific actions taken by KFP for sustainable concrete construction? What are the durability parameters specified for concrete to increase the service life in state?
Can you repeat it? What are the actions taken by KIFB?
What are the actions taken, specific actions taken by KIFP for sustainable concrete construction? What are the durability parameters specified for concrete to increase the service life in state specifications? Are we seriously approaching this issue? Sham Kumar Sham Prasad is asking this question.
Okay. I am an advisor to KIFB at the moment, but at the same time, I can't speak on behalf of KIFB. So that's a separate issue. I am talking because I am also the chairman of the cement and concrete for the BIS. So what I have been discussing was basically what is the Bureau of Indian Standards action taken. So there are two stages. One was we brought in the chapter on approach to sustainability through the National Building Code, the chapter 11, which has already come. I have read out in this presentation all those parameters that are to be considered for across the construction, right from site selection until repair, maintenance, and everything. So that is the approach that you want us to take. Second is the improvements that have been brought in the national codes, like the IS 456 and other codes. So that is what I have mentioned in the 383 and other places. What are the sustainability and durability? What are the new provisions which has been brought in the IS standards, BIS standards, has been discussed in my presentation. This is what we have done. And the previous construction in Kerala, what I have done, if you want Kerala, I have put the environment parameters in the construction agreements. We said everybody at the construction at the site, we have to monitor the quality of the groundwater, the quality of the dust in the air, as well as the noise levels at different intervals, and see that those issues are not violated. And if you violate, what are the compensations and penalties that are to be imposed? So this is part of the agreements that we have created. So similarly, for these new projects, we have introduced these environment monitoring parameters to be monitored in each of the agreements which are going to come in the new works which are going to be put into after the corona issue. We will be putting those environment parameters which has to be monitored and audited. So this we are already included in the agreements. draft agreements. Is it satisfies you? Hello.
Yeah. What is the next question?
Yeah.
What is the water cement ratio we need to maintain when we are working underwater concreting, especially in seawater? Mr. Ramesh Rao is asking this question.
As undersea water.
Yeah, underwater concreting, especially seawater. What is the water cement ratio?
So
Ramesh
underwater concreting, I am not an expert on underwater concreting, so I can't answer you straight away. But if you send me the specific question, I can discuss with some people. I can definitely answer you. But normally, the stiff concrete is sent down. I mean, when we use for well foundation and other things, we have done some underwater concreting, but not under sea water. I definitely not use that, and I am not in a position to answer you straight away. But if you raise the question, I can definitely answer after consulting experts. Okay. Hello.
Another question. What will be comparison of between PPC and PSC? Mr. A.S. Purana.
PPC and
PSC. PSC.
You mean slag cement?
Yes.
Slag cement.
Yes.
See, we were, or the entire construction industry was quite reluctant to use PPC some time back. But now both all the departments, government departments, and the standards have now introduced PPC and PSC as a usable cement in construction, and it has become extremely popular. Now a stage has come. Now you can't get the other type of OPC in the market. That the kind of situation has come, because PPC has got tremendous advantage. One, it is more environmental friendly. That's no doubt about it. But at the same time, the quality in terms of its durability is much higher when compared to structures constructed with OPC. So this is the situation, because the permeability, the impermeability has definitely improved. With the result, the durability has got a tremendous advantage when we use PPC cement. But you know that the quantum of the chemical, mineral admixtures are limited to 35%. Whereas in the PSC, we use slag. Is equally a good material, no doubt about it, and it has got additional advantage that it can be used in places where surface attack and other such specific places. But in the eastern sector of India, slag cement has become very immensely popular. The code what is prescribed it, but the slag should be at least more than 50% to make it a durable material, and new durable material. That was the prescription. Both are excellent materials, no doubt about it. Unfortunately, we have not graded them, but I hope it will happen very soon. Okay.
How to avoid carbonation in the presence of humidity? Mr. Prayas Jain is asking.
Carbonation, humidity, I have not understood what exactly. Carbonation, humidity has no relationship. Don't worry about that one. Carbonation is a different problem that happens due to other parameters. Humidity is definitely not an issue. Don't worry about that one. Carbonation happens due to other presence of, both parameters in the concrete as well as the external surfaces, but mostly due to the cement itself, the type of cement and the aggregate which has been used.
Mr. Achyut Manan is telling, he's sending a compliment. Experience with you, made a wonderful speech. CPW is proud of you. Mr. Achyut Manan is sending his compliment. Another question.
Thank you very much, Achyut. Thank you very much. Yeah.
Can we use LC3 material in sustainable concrete? Hemraj.
Yeah. Yeah, please go ahead. No problem.
Portland composite cement. Mr. A.S. Kurana is just writing Portland composite cement. Maybe he wants to know some information. Portland composite.
Yeah. This is an area in which we are still working. In other internationally, composite cements are used, no doubt about it. But our standards are still not developed to that extent. Studies are going on some of the national laboratories about this work. Very soon, we will also, our standards also will come out with parameters as well as provisions in the things. Right now, we are on a transition stage. We are not at fully sure about this one, so studies are going on.
Why red mud waste from alumina industry as a cement fine sand is not being incorporated in codal practices?
Which waste is talking about? Huh?
Why red mud? Red mud waste.
Yeah, red mud is possible. Studies are going on in some of the national laboratories. I think it has happened in couple of national laboratory studies have taken place. In fact, they produced recast concrete also using red mud, but it can be used, but it has not been incorporated in the codes yet because a lot of studies are required and pass the several tests before we can accept it. As far as I understand, we are not included it in the codes, national standards, even though it is mentioned as a possibility.
Yeah. That's all. No more questions.
Yeah.
Sir, we thank Engineer Jose Korean, sir, for a wonderful lecture. A lot of information. In each slide, we could see his experience and expertise showing up. We are really blessed to have him today for this webinar. We also thank all participants who have taken interest to attend this program. As I said earlier, Mr. Jose Korean is I can say, a walking encyclopedia. All the participants can get in touch with him and also can write to QCrete. We can just send back the answers for the questions. Finally, we thank our MD, Mr. Shelly Fernandez, for initiating such a great talk by, I can say, legendary civil engineer, Mr. Jose Korean. Thanks a lot, sir. Thank you very much.
Thank you very much. Thank you. I thank all of you who have worked very hard for this one, especially Shelly. He has been after me for quite some time and spent a lot of time in preparing this particular topic, choosing the topic and presenting it this way. I thank all of you, all the audience who are patient to listen. And in case you have any specific questions, please get through to me or to QCrete. We will definitely respond to that. Thank you very much for the attention.
Thank you, sir. Thank you.